Good morning. Today is April 1st, right? April 1st. There it is. April 1st, which is known as April Fool's Day, but is also known as Matthew Morgan's 23rd birthday. Anybody who knows Matt, wish him a happy birthday. All right? Hope this finds you guys doing okay, right? We're kind of trudging through here. Maybe doing it a little longer than we thought. But hang in there and always know you can ask me questions and we'll figure it out, okay? So this PowerPoint is actually going to revisit some equations that we've worked with in the past, just using them in different story problems having to do with CDs and money market accounts, right? Because that's what we're talking about in this chapter, different ways to save your money. This first equation we briefly looked at in the last video, but this is called, when you're comparing savings plans, what the banks or the financial institutions will give you is this annual percentage rate. And that's a rate based on simple interest, meaning compounding once a year. But what you want to understand is if there's compounding more than once a year, what rate are you actually getting? So this is your annual percentage yield. This is what you're actually getting when you take into account compounding. So for us to take the APR, which is R is the APR. Whoops, ARP, no, APR. And if we're going to kind of translate that into what you're actually getting, the annual percentage yield, you're going to take into account, right, the rate, and then K, which we called N, is the number of compoundings per year. Okay, pretty simple to use, but we'll look in the next slide. So it says you are comparing two savings accounts. The first pays a rate of 4%, right, compounded monthly. The second pays a rate of 4.05% compounded annually. So notice, if I remember that the APR, the rate they give you, is what you would have if you compounded annually. So if I use this equation, APY equals 1 plus the rate, is 0.0405 over 1 raised to the 1 power minus 1, just gives me 0.0405, gives that right back, because APY, what we're getting, is the same as the APR since it's compounded annually. Now let's consider this savings account. So we want to say, what is our annual percentage yield? If it's 1 plus 0.04 divided by monthly, so that's 12, right? Raised to the 12 minus 1. I'm going to put that in my calculator. I haven't done this ahead of time. So 1 plus 0.04 divided by 12. Going to raise that number to the 12, and I'm going to subtract 1. Notice what we get here. 0.4074, blah, 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 blah. So if I want to know which savings account has a higher APY, it's this one, isn't it? It's only by, we're at this decimal place, but still, every cent counts. Okay? So this is an example of using this equation. Now, the equations that we're bringing back to the front of our head that we used before were these two, right? Here's if you had simple interest, meaning compounding annually, right? Where N equals 1, or in this case, they're using a K, same thing, or if you compound more times a year. So they're saying Synchrony Bank offers a 3.10% APY for a 3-year full 3-year CD. How much will he earns if he deposits this for a full 3 years? So notice they just gave us an APY. There's no talk of compounding. So that means this is a compounding annually. Okay? So first, I'm going to use my equation right here, gang. Because this is going to tell me what's in his account at the end of the 3 years. So it's going to equal the principal, right? 1 plus the rate, 0.0310, raised to the t, 3 years. Okay, so let's do this. 1.0310. I'm going to raise that to the 3 years. I'm going to multiply by 1,500. So in our account, we have 16,438.69. So remember, when we did a test on this, we said how much of this was principal, how much of this is interest. So this is the total. If I take off his $15,000 principal, he earned an interest of 1,438.69 in those 3 years. All right. So like we said, in this case, they're giving us an APY, aren't they? They're not talking about compounding at all. So that means compound annually n equals 1. So this is how much interest they'll make. All right, moving on. Let's look at this one. So Michael put $17,000 in a CD, 6 months. Notice this. 6-month CD paying this annual interest. Okay, doesn't talk about compounding, does it? He needs to withdraw $4,000 to pay an unexpected bill. The penalty for early withdrawal is 1 month's interest. What is his penalty? Okay. I don't think we can answer this part of the question because I didn't tell you when he made the withdrawal. But we can talk about what is his penalty. So we're going to calculate how much interest he will make in this CD for 6 months. And then his penalty is 1 month of interest. So we'll divide it by 6. So this is the equation we're using, right? What would he have in his account if he left it? 1 plus the rate. Now, raised to the t. So it's 6 months. T is in years, isn't it? So we're going to raise this to the 1/2, 6 out of 12 months. All right, let's see what would be in his account if he left it. He would have had 17,194.39. It doesn't seem like much, but he's only in there for 6 months. So if I take off the $17,000, right, he would make this much interest in 6 months. So I'm going to divide that by 6. So his penalty is 1/6 of the interest he would have made, and that was $21.60. That's all we're doing here. We're using this equation again because it's simple interest, right? They don't talk about compounding anywhere in this equation. You got to watch the time because 6 months is this much of a year. And then figure out his total interest and divide by 6. Okay? Let's look at the next one. Effective rate of interest. So this is something where if you knew what you deposited and you knew how much you had at the end of the time period, we're going to calculate the effective rate of return. We're going to calculate the percentage. So here's our formula. Total interest earned divided by the original deposit. So you deposit $1,000. You earn this much in interest. What would be your effective rate of return? 4.0 divided by 1,000. So your effective rate of interest is 0.0407, right? Over this 1 year. Isn't much, is it? Why is this looking so small? Well, in this problem, they only earned 0.407%. Guess what? You need to stay away from savings accounts that only earn you that much money. But the reason we're doing this problem is to show you the formula. So there's the formula for effective rate of interest. Okay? Now, you are going to do maybe 5 problems on a worksheet that uses these different equations. Okay? Email me if you have any questions. These are going to be due for everybody. I think 7th hour you'll be due this Friday. No, not Friday. Tomorrow. And because we don't have school Friday, 1st hour will be due Monday. All right. Please let me know if you have any questions. Thanks.